Grade 11, so I hope you are doing well. Today we're looking at stoichiometric calculations, and it's a big word, but it's really not that difficult. But it is a very, very important part of chemistry. So first of all, this is about having your having questions regarding chemical reactions and how to do calculations regarding this, because we are talking about quantitative aspects. Okay, so we're talking about moles, grams, and volume and things like that, right? So first things first is always in your calculation, after you've read the question and understood what's being asked, is to write down the balanced equation of the reaction. You cannot solve anything if you cannot balance that equation. So you have to do that first. Then you have to calculate the relevant molecular mass or volume depending on the question. And then from there on, calculate the unknown for whatever is being asked. Okay, so it always takes this approach. So I'm going to explain it in the following way. Okay, it always takes this approach. They give you some information regarding the products or the reactants, doesn't matter, and then you use the equation, the balanced equation, to solve the other one. Now this is literally like getting onto a train at a train station and getting off at the other side. So normally the information is given either in mass or mole or volume, depending on your question. So this is given for, let's say, two of the products, the reactants, I mean. So we always convert whatever is given to moles, because this reaction, our equation, only works with a molar ratio. These A, B, C's, and D's, these are molar ratios. They're not mass ratios. They're not volume ratios, except when this is a volumetric reaction only. Okay, so you have to keep that in mind. So we always convert whatever is given into moles. Even if it's the volume, and it is a volumetric reaction, then you take the volume to moles and you react with the moles, and then you, like I say, you get onto the train by converting to moles. Then you move across by using your ratio, and then you get off depending on what was being asked. So now you can calculate whatever is needed, like mass, volume, whatever is needed. So this is the basic foundation of stoichiometric calculations. Okay, I would like to work through two examples with you in this section of the work. So the examples are on page 191 and 192. And please follow carefully how I go through the calculations. Okay, so this example, they tell us that a thermite reaction, aluminium, reacts with iron oxide in a very exothermic reaction. So we have aluminium, which is a solid, and it reacts with iron oxide. And it produces iron and aluminium oxide. Okay, so it produces iron and aluminium oxide. Let's talk about the phases quickly. So iron oxide is a solid. Iron in this case would be a liquid because of the highly exothermic reaction, and the aluminium oxide would also end up as a solid. So this is our reaction. Okay, now they tell us, if 100 kilograms of aluminium is available for the reaction, how much iron oxide is needed? Okay, so that's the question. How much? Well, we are going to talk about mass. Okay, So let's talk about the concept again. We have mass, we're going to convert it to moles, and then use the molar ratio, which we're going to calculate now, to get back to mass again. By using, and how do we get to moles? We use the molecular mass and the molecular mass. Okay, first things first, let's balance this equation. We've got one aluminium, 2 on that side, so we're most probably going to have to put a 2 there. Okay, 2 aluminium, 2 aluminium. 2 iron, 1 iron. So we have to put a 2 there with iron. 3 oxygen, 3 oxygen. Okay, it is balanced. Now we can start the actual calculations. Okay, so we first have to go towards moles. So to do that, we have to get the molar mass of aluminium. So for aluminium, we know that according to my periodic table, let me just get my periodic table quickly. We know it is 27 grams per mole. Okay, so molar mass for aluminium is equal to 27 grams per mole. Therefore, the amount of moles if 100 kilogram reacts, right? The amount of moles will be as follows. Mole equals mass divided by molar mass. Mass is 100 kilogram. Remember, that's 100,000 grams. But we don't have to work with kilogram like grams and a mole. We can work with kilomole as well. So it really depends on how you would like to work with this. But let's stay 100,000. And the molar mass is 27. Now we can calculate. So it will be 100,000 divided by 27 is 3,703,7 mole. Okay, so what did we do? We got onto the train. You understand that's analogy, right? So now we know how many moles of aluminium react. Okay. Next step, look at the ratio. For every 2 moles of aluminium, we need 1 mole of iron oxide. So now you say that, then now you write that out. You say 2 mole of aluminium needs 1 mole of iron oxide. Therefore, and now we take the 3,703.7 divided by 2. Therefore, we need 1,851,85 mole iron oxide. Okay, so what have we done? We've gone from the 100 kilograms to the actual reaction, and then you got onto the train, to molar, right? Molar ratio. Then we move to through molar ratio to this one. Now we just need to convert it back to mass. Okay, so molar mass for iron oxide. So according to periodic table, iron's molecular mass is 55.8, right? So we've got 2 of them, so it's 2 times 55.8 plus 3 times an oxygen, which is 16, right? And we calculate that. And then we get 159.6 grams per mole. Okay, remember this is our way of getting back to mass. Now we can calculate the mass of iron, right? Which is moles times molecular mass. So we've got 1851.85 times 159.6. So if we do the calculation, we get a huge number, right? 29555.26 grams. Therefore, we can write it down in kilograms as well. It's 295.56 kilograms. And that is the amount that we needed. Okay, I will do a second video on this. You will clearly see that the way that they solved it in the textbook was much different from the way that I did it. Okay, but I feel the way there was very confusing, and it's not possible to use that same method for various calculations. So what I'm teaching you now is a method that you can use for any type of calculation with stoichiometric calculations. So yeah, stay tuned for the second video.